Okay, so these are the extended important questions concerning energy conservation. We have a heavy box that is dropped downwards. If it reached the floor at a speed of 3.2 meters per second, then from what height was it dropped? I like to draw an illustration of the question that we have. So that's the box, and that's the ground, and this is the height that the box originally was dropped from. We don't have the mass, as you can see, but we need to find the height. The only thing given here is the speed or the velocity of the box while it's falling down until it reached the floor. So the thing is that when the box was lifted, it had GPE, and as it falls down, all this GPE is converted into kinetic energy. So we can say that the gain, the loss in the GPE is equal to the gain in the kinetic energy. So mgh is equal to half mass velocity squared. We can cancel both masses from both sides, and then we will get the height is equal to half velocity squared over the height. Replace everything, over the gravity. Okay, taking this to the other side. Now replace everything by the given 3.2 squared over 10, and the answer that you will get is 0.5. So this is equal to 0.5 meter. Okay, second question. Now we have a heavy object that is dropped from a vertical height of 8 meters. We need to find the speed. So it's, if you want, pretty much the same concept as this question. This one, yeah. But this time we need to find the velocity, and the height is given to us. So again, we say the loss in the GPE is equal to the gain in the kinetic energy. So mgh is equal to half mass velocity squared. Once again, we don't need the mass as it will be cancelled out. We need the velocity squared, so I'll take this to the other side. It will be 2gh, and then we can say that v is the square root of 2gh. By replacing everything by everything that is given to us, we'll have 2 times 10 times 8, and the answer is 12.65 meter per second. Okay, so if this is the ground, and that's the building that the Smurf was initially thrown from, and that's the Smurf. Okay, so it's 10 meters away from the ground. We know that before landing on the ground, the Smurf here had a velocity final equals to 18 meters per second. Our purpose is to find VI is equal to how much in meter per second. Okay, so we will use the energy conservation. Initially, the Smurf was raised above the ground, so it has GPE. And initially, the Smurf was thrown with a speed, a velocity VI, so it will have a kinetic energy as well. So final, the Smurf will hit the ground, so we will no longer have any GPE. So you can write it, but it will still be 0. And the kinetic energy final is still there, since he lands with an 18 meters per second. Now we can replace the formula of GPE and KE. So mgh plus half mass velocity initial squared is equal to half mass velocity final squared. You can see how we have mass, and mass before and after the equal sign, so we can get rid of it. So we will have GH plus half velocity initial squared is equal to half velocity final squared. The equation is getting simpler. Highlight the thing that we need to find. This is the thing that we need to find. So we need to rearrange the formula in order to get the subject. By taking GH to the other side, and since it's plus over here, so it will become minus. So we will have half velocity initial squared is equal to half v final squared minus gh. Now in order to take this to the other side, it was a division here, so it will become a multiplication. So vi squared is equal to 2 multiplied of v final squared minus gh. So vi is the square root of 2 half final velocity squared minus gh. Okay, so let's substitute now everything. 2 multiplied by half, the velocity is 18 squared minus, okay, so this one minus 10 times 10. And on the calculator you will get, so square root of 124 is 11.13 meter per second. Okay, now we have another Smurf that is now thrown horizontally from a 50-meter cliff at 8 meter per second. So we have the altitude, we have the vi, to another 50-meter that is away from the ground. We want to know how much ke does it have when he reached the 50-meter cliff. So here we don't want to find the final velocity, we want to find the kinetic energy final, all of it. So once again, I like to make like a drawing. So that's the ground, an illustration for the problem that we have. That's the 50-meter cliff, and that's the other 15-meter cliff. That's the Smurf, and the Smurf was thrown until the Smurf lands over here. The Smurf was thrown with a velocity of 8 meter per second. Yeah, that's it. Now we need to find the final kinetic energy. So once again, we will say GPE initial plus KE initial is equal to GPE final plus KE final. Okay, in such case, we will not cancel the GPE final because the Smurf will land on a cliff that is also, it has an altitude away from the ground. So we need to just substitute by everything that we have. We have mgh I, if you want, that's hi, and that's hf, plus half mass velocity initial squared is equal to mgh final plus, I will not develop this because I need it as it is, so I'm just gonna keep it. Okay, so now mghi plus half mass velocity squared minus mgh final is equal to kinetic energy final. So the mass of the Smurf is the same mass multiplied by 10 multiplied by 50 plus half times the mass times 8 squared minus the mass 0.575 times 10 times the final, it's 15. That's KE final. So by doing the math calculation, you will get 219.65 joules. Now if I had one more question, that is, then you will say, we know that the kinetic energy final is half mass final velocity squared. That's 219.65. That's 0.575. So rearrange the formula to get 219.65 multiplied by 2 over 0.575, and then you do square root of this would be 27.6 meter per second. Okay, now question 5. We have a box that is sliding down a frictionless lamp. If it starts at rest, what is the speed at the end? So that's the box. We want to find out what is the speed of the box at this position. This is called the final velocity. Okay, so initially the box was raised to an altitude of 4 meters above the ground, right? So this means that the PE initial plus KE initial is equal to GPE final plus KE final. That's the rule. But since the box starts from rest, so no motion initially, and since the box will reach at the end the bottom, so no altitude away from ground at the end. And so the equation will be simplified to GPE initial is equal to KE final. Initially the box was mgh, had an energy of stored in it as mgh, and then it became half mass velocity squared. We can get rid of the mass on both sides, simplifying them. So we will get 2gh is equal to the velocity squared. So the square root of 2gh is the velocity, and so the answer is 8.94, which is around 9 meters per second. Okay. For question 6, we have a roller coaster car that starts from rest at point A. We want to find the speed of the roller coaster at point C. So at this position, what is the velocity? If the track is, again, it's frictionless. So we will say GPE initial plus KE initial is equal to GPE final plus KE final. Initially, the car starts from rest, so no motion initially. We do have kinetic GPE as it's raised 12 meters above the ground. At the end, it's still raised 4 meters, so we will still have some gravitational potential energy, and then the final velocity in order to find the KF. So we will say mgh I is equal to mgh F plus half mass velocity final squared. We can simplify by m, and so we will get ghi is equal to ghf plus half velocity squared. Take this to the other side, so it will become ghi minus ghf is equal to half velocity squared final. Now take the half to the other side. It will be ghi minus ghf multiplied by 2 is equal to vf squared. So vf is equal to the square root of 2 multiplied by gh initial and gh final. And by doing the calculation on the calculator, we will get 12.65 meter per second. Okay. Last question. We have Tarzan that is running at 3.5 meters per second, and he wants to grab the rope that is hanging vertically like that. We want to know how high will he swing. So it will be GPE initial plus KE initial is equal to GPE final plus KE final. Now, since he will swing up, to a maximum altitude that we want to find above from the ground, that's the ground. So since he's gonna swing up at this position, the maximum height, the kinetic energy is 0. Okay, we have a gravitational potential energy due to the height. Initially, he was still on the ground, so his GPE initial was 0. And so the equation is simplified to half mass velocity squared initial and mgh final or maximum. Simplify by m on both sides. We want to get the height, so half vi squared divided by the gravity is equal to the height final. So rearrange all the formula and substitute in order to get what? We will get 0.61 meter. Okay, now the question is, if his GPE is 490 joules, what is his mass? So this is a very direct application for the formula. We know that GPE is mgh. We just got the h, so we can say GPE over gh is m, and so m is GPE 490 over 10 multiplied by 0.61. The mass will be around 80 kilograms. And yeah, that's it.